The transition to electric vehicles, EVs, is often hailed as a major step toward reducing carbon emissions and creating a more sustainable future. However, while EVs promise cleaner transportation, their batteries present an often overlooked environmental and economic challenge: recycling. Lithium-ion batteries, which power most EVs, come with a complex life cycle that includes mining, manufacturing, use, and disposal. While much attention is given to their role in reducing tailpipe emissions, less is said about what happens when these batteries reach the end of their useful life. EV battery recycling is crucial for sustainability, but it comes with significant hidden costs, both environmental and economic. Let's explore the complexities of battery recycling, its unintended consequences, and what the future holds for sustainable recycling solutions. Before we proceed to the video, don't forget to hit the like button and ring the notification bell so you never miss our upcoming videos. The rise of EV batteries. The demand for EVs has surged over the past decade, driven by stricter emissions regulations, technological advancements, and growing consumer interest in sustainable alternatives to fossil fuel-powered vehicles. Governments worldwide are setting ambitious targets to phase out internal combustion engines, further fueling the EV market's expansion. At the heart of this revolution lies the lithium-ion battery. These batteries are favored for their high energy density, long cycle life, and ability to power modern EVs for hundreds of miles on a single charge. However, as EV adoption increases, so does the number of used and discarded batteries. By 2030, an estimated 12 million tons of EV batteries will reach the end of their life. Without efficient recycling systems in place, these batteries could become an environmental and economic burden rather than a sustainable solution. The complexities of recycling. Recycling lithium-ion batteries is far more complicated than recycling conventional lead-acid batteries used in gasoline-powered cars. Several factors make the process challenging. 1. Complex composition. EV batteries are not a single unit. They are large, multi-cell packs containing various metals like lithium, cobalt, nickel, and manganese. Extracting these valuable materials efficiently is technically challenging and expensive. 2. Safety concerns. These batteries can catch fire or explode if improperly handled. Due to their high energy density, improper dismantling can lead to hazardous chemical leaks or thermal runaway events, making recycling a dangerous process. 3. High energy and resource requirements. Current recycling methods, such as pyrometallurgical, smelting, and hydrometallurgical, chemical leaching, techniques require significant energy input. Smelting, for instance, involves heating batteries to extreme temperatures, which releases greenhouse gases and consumes vast amounts of electricity. 4. Economic viability. Extracting and refining materials from used batteries is still more expensive than mining fresh materials. This discourages large-scale investments in recycling facilities, limiting the number of operational plants worldwide. These challenges highlight why the majority of EV batteries today are not fully recycled. Instead, many end up in landfills, or they are repurposed for second-life applications in energy storage systems. Hidden environmental costs. While EVs help cut down carbon emissions from transportation, their batteries come with hidden environmental costs that often go unaddressed. 1. Mining and resource depletion. Lithium, cobalt, and nickel, the core components of EV batteries, are extracted through resource-intensive mining operations. For example, lithium mining requires millions of gallons of water, leading to water shortages in regions like Chile and Argentina. Cobalt mining, concentrated in the Democratic Republic of Congo, raises concerns over deforestation and human rights violations. Recycling should ideally reduce the need for new mining, but with current inefficiencies, mining remains the cheaper option. 2. Toxic waste and pollution. Improper disposal of used EV batteries can lead to the leaching of toxic chemicals into soil and water. Elements like lithium and cobalt can contaminate ecosystems, harming wildlife and human health. Additionally, pyrometallurgical recycling releases harmful emissions, including carbon dioxide, sulfur dioxide, and heavy metal particulates, contributing to air pollution. 3. Carbon footprint of recycling facilities. Ironically, some battery recycling facilities have their own significant carbon footprint. The energy-intensive nature of the process can offset some of the emissions savings gained from using EVs in the first place. For EVs to be truly green, we need a circular system where batteries are efficiently recycled without excessive environmental harm. Economic and societal impacts. The hidden costs of EV battery recycling are not just environmental. They also carry significant economic and societal consequences. 1. High costs and limited profitability. Despite the valuable metals contained in EV batteries, recycling remains costly. Many companies hesitate to invest in large-scale recycling facilities because the financial returns are uncertain. For instance, recovering lithium from old batteries is 5 times more expensive than mining fresh lithium. Until recycling technology becomes more cost-effective, businesses will continue to favor newly mined materials. 2. Job market shifts. The shift to EVs and battery recycling is also reshaping the job market. Traditional auto mechanics and fuel industry workers face job losses, while new jobs in battery production, recycling, and energy storage are emerging. However, retraining workers and ensuring a smooth transition remains a challenge. 3. Ethical concerns. Many EV battery components, especially cobalt, are sourced from regions with poor labor conditions and child labor issues. If recycling were made more efficient, it could reduce reliance on unethical mining practices and create a more responsible supply chain. The future of sustainable recycling. Addressing these hidden costs requires innovation, policy support, and advancements in battery technology. Several promising solutions could reshape the future of EV battery recycling. 1. Second life batteries. Before being fully recycled, used EV batteries can be repurposed for energy storage systems, such as grid backup or solar energy storage. This extends their lifespan and delays the need for energy-intensive recycling. 2. Advanced recycling techniques. Newer direct recycling methods aim to recover battery materials without breaking them down into raw elements, making the process more efficient and less energy-intensive. Emerging technologies, such as mechanical separation and solvent-based recovery, could make battery recycling both cheaper and more sustainable. 3. Policy and regulation. Governments worldwide are introducing stricter regulations on battery disposal and incentivizing recycling. The European Union has set battery recycling targets, and the U.S. Department of Energy is funding research into sustainable recycling solutions. Stronger policies will push manufacturers toward closed-loop recycling models, where old batteries directly contribute to new ones. 4. Battery innovation. Future battery designs could eliminate the need for problematic materials like cobalt and nickel. Sodium-ion and solid-state batteries are being explored as alternatives with better recyclability and lower environmental impact. 5. Manufacturer responsibility. Companies like Tesla, Nissan, and Redwood Materials are investing in closed-loop recycling programs, ensuring old batteries are reused efficiently. Producer responsibility laws could make it mandatory for all EV manufacturers to take back and recycle their batteries, reducing waste. EVs are a crucial part of the transition to a sustainable future, but the challenge of battery recycling cannot be ignored. While EVs reduce tailpipe emissions, their batteries introduce new environmental, economic, and ethical concerns. Recycling technologies are improving, but without cost-effective and environmentally friendly solutions, battery waste could become an unintended consequence of the EV revolution. To achieve true sustainability, we must develop efficient recycling processes, invest in alternative battery technologies, and implement stricter policies that promote responsible battery disposal. Only then can EVs deliver on their promise of a cleaner, greener future without hidden costs. If you enjoyed what you saw, don't forget to hit the like button and ring the notification bell so you never miss our upcoming videos. Your support means a lot to us. Take care until the next one, and feel free to drop a comment sharing your thoughts. See you soon.